Hello and thank you for joining this virtual presentation. My name is Georgios Bairaktaris. I am a PhD student at the University of Surrey, and today I will be presenting an optical flexible bookmark for open page detection in augmented paper applications. I'm going to start this presentation by describing the problem and then head on to a quick review of the state of the art before moving on to our solution and how we used hybrid electronics into physical paper books. We all know that flexible and printed electronics can be used in a wide range of applications that require features like conformability, small form factor, and so on. This specific work is focused around the application of smart paper. A quick search shows that citations around interactive and augmented paper are rising even though they remain low. However, user studies and research shows a growing interest in the human-computer interaction community. The main problem in this area is the static and limited nature of the information printed on paper. Digital media are rich in content and contain immediate and up-to-date information. However, paper has a unique physical feel which cannot be replaced by paper-like devices such as tablets and e-readers. User studies have shown the value of paper and the instinctive preference of people towards this physical medium. This is not a new problem, but the technology is only just now getting there to address it properly. In fact, the first attempt at augmented paper is from Wellner with the digital desk at 1993. The proposed system was using an early form of image recognition and augmented reality to read documents on a desk and overlay additional information or other digital documents. The technology available at the time, of course, meant that the system was far from portable and practically had to be installed in a whole room, but the augmented paper logic was there. It just needed a smaller form factor that could be integrated with the user's behavior in a more seamless way. The most challenging part of augmenting a paper object is detecting the active page, the page that the user is reading. The latest solution in the literature for open page detection is that proposed in 2020 by Bailey in the form of a digital bookmark. The application here differs from the augmentation of paper. Instead, his proposal is used to synchronize digital and paper versions of the same content instead of providing additional digital content. The technique itself is using printed silver conductors on each page to create a unique binary code that is detected by the readout electronics. The device itself is quite big and hard to handle, and the integration with the book is somewhat poor. Additionally, the printed conductors on each open page of the book result in much higher fabrication costs and more changes in an existing printing and binding workflow for a book. So, this is where flexible and hybrid electronics come into play, providing the answer to these manufacturability and integration problems. Hybrid systems combine the functionality, superior performance and stability of conventional electronics with the flexible and lightweight aspect of printed electronics to create high-performance hybrid systems that are overall lighter and partly conformable. In this work, we're utilizing the current status of printed electronics to create a sustainable and manufacturable ecosystem to address a real-life application, the augmentation of paper. At this point, I should briefly mention the Next Generation Paper project, which is our own multidisciplinary attempt at augmented paper. The project is addressing the problem holistically, with the development of technical solutions, user studies, commercialization studies. The open page detection here is automatic through these printed organic photovoltaic sensors that are laminated and hidden between the paper pages of the book to create a unique binary code which represents the page number. This technology comes with its own problems and challenges such as handling, robustness and fabrication issues that were used as a starting point for the Magic Bookmark ecosystem that we're proposing in this work. The Magic Bookmark. The Magic Bookmark is an open page recognition platform that can be seamlessly integrated with both soft and hardcover books for augmentation applications. The idea is based around integrating printed and conventional electronics in a flexible bookmark which detects the active page. The control electronics then transmit this information to a connected digital device, which could be a screen around us, a TV, a mobile phone, a monitor in a classroom, and so on. Relevant additional digital content, website, videos, photos, music, clips appears on the adjunct device, which can be consumed in parallel to the printed information. The aim is to optimize the integration of the sensing system with the paper book without compromising the reader's experience and in a sustainable, robust way that is easy to fabricate. For that, we have prototyped 3 different techniques for open page detection. The first technique is using printed conductive patches on the pages of the book, similar to the digital bookmark by Bailey. These create a unique binary pattern on each page, and printed conductive switches on the bookmark are triggered when placed on the book. This method requires precise alignment and firm contact pressure, which adds complexity to the actual interaction and can be prone to errors. The second technique is using a series of photodiodes to detect the presence of paper through a pattern of cutouts on the previous page. This method is much more reliable from the previous one, but it means that the device must be placed after the active page, which deviates from a typical interaction with the bookmark, and we are aiming for a zero delta interaction. What this means is that we want to augment and enhance the functionality of books, and generally everyday objects, by abstracting the electronics and without changing the way people already interact with them. The last method is using a reflectivity sensor, which is practically a combination of a phototransistor and a photodiode, to read a barcode-style pattern on the active page. This technique creates a very seamless interaction and can be further abstracted from the user by incorporating the optical barcode with the existing graphics of the book that we want to augment. The prototyped control electronics were made compact on a flexible carrier with the bookmark sensor combined, and they can be attached to any compatible book that has the optical markers. The surface of the bookmark could be used to further increase the functionality, either by generating energy from available light or by including other sensors such as touch, pressure, temperature, or to provide additional means of interaction. All techniques were prototyped using printed conductors and hybrid integration on a PI substrate. Dispenser printing was used to apply the conductive layers, and PI tape was used as the insulator. The electronic components, including the sensors, the MCU, the communication and power management ICs, were all attached with the standard reflow process of solder paste. A PDMS layer was used as an encapsulation layer and as a light guide to provide control over the distance between the sensors and the page. The final device was tested against various angles, imitating the use of a typical bookmark to confirm the functionality of the device. The recognition of IR absorbance is overall reliable and consistent, but capturing the reflectance of the IR with the sensor at an angle of 45 degrees or higher becomes challenging as the output voltage approaches the logic level threshold. This should be taken into account when designing the system, as it will have an effect on the way the readers must use the Magic Bookmark. Overall, we have demonstrated how the current status and opportunities of printed electronics can facilitate the integration of electronics with conventional objects such as books. However, our final goal is to demonstrate the sustainable functionality of a fully printed system. Therefore, the next steps of the project include the development of fully flexible and printed active devices that will replace all the sensing elements of the bookmark, thus making it smaller and better integrated with the book. The focus here is not high efficiency or improved performance, but a robust, functional platform tuned to the requirements of a specific application. So to summarize, the Magic Bookmark ecosystem is a paper augmentation platform that is using gestures natural to the book reading experience. Our solution improves upon both our previous page recognition strategies and the current state of the art in the HCI community by increasing the manufacturability, robustness, and cost effectiveness of augmented books. We have used hybrid integration to develop and prototype the various concepts, and the final goal is to demonstrate a hybrid system that is utilizing as many printed components as possible that have been specifically developed and tuned for the application's needs. Thank you very much for your time, and I hope you enjoyed the presentation. For any questions, please join the live session or send us an email at the address on the screen.